Select the major product of the following reaction. So if we look at our starting materials, the first thing we'll see here is bromobenzene. So this bromine is directly attached to a carbon atom of the benzene ring. So this is known as an aryl halide, specifically a bromide, but this could also be something like chlorine or iodide. And then if we look at our next reagent, we've got this terminal alkene and we've got an ester. So it is the terminal alkene that is going to be important for this reaction. The ester is electron withdrawing, which does help the reaction take place, but we're going to focus on our chemistry on the alkene. And so we're going to see that we're bringing this together. L2 is generically saying we've got two ligands. So two things attached to this palladium. And so that palladium is the catalyst for the reaction. And we've also got triethylamine, which is a base. So seeing these conditions together, a halogen that's attached to an sp2 carbon, in this case an aryl ring, a terminal alkene, palladium catalyst, and a base, we should be recognizing this as an example of a Heck reaction. And so what's going to take place in a Heck reaction, it's a coupling reaction, bringing together the carbon atom that your halide is attached to, that sp2 carbon atom, and the carbon atom of the terminal alkene. So being terminal, this alkene at the moment does not have stereochemistry, but when we form a new bond between this carbon and this carbon, we will be having stereochemistry. So specifically, there are two hydrogens attached to that alkene. We're going to replace the hydrogen that it has trans to the other group. So this one is trans. We're going to replace that with the bond to the carbon atom of the benzene ring. So I think to draw this product, I'm going to start with drawing the alkene. And I chose to start there so I can really think about the stereochemistry. And I want this to become a trans alkene, so I make sure the bond is trans. And this bond is going to be the bond to the benzene ring. Okay, so we can see the two carbon atoms that we brought together, the one of the benzene, the carbon atom of that terminal alkene. This here is our new bond. And we want to note that stereochemistry of the alkene as being trans. And if we take a look at our options, we can see that what we've drawn up here is matching C.